Right. Thank you for your patience, everyone. Um, hello. So welcome to the afternoon session. And hi, Adam. Um, he's here to present Fedora CI and automated testing and where we are at it. Right.
Hello. Hello. Okay. We're working. How's everybody doing today? Hello, Boston. Okay, I guess we'll get started. I am Adam Williamson. I'm a senior principal software quality engineer at Red Hat. It is, and I believe we keep changing our job title to be closer to software engineer in the hopes that software engineers will respect us and invite us to their parties. So yeah, that's me. Um, more importantly, I'm the sort of the team lead for Fedora QA at Red Hat. So when Fedora breaks, it's my responsibility. There are going to be no funny pictures in this slideshow. I'm sorry, I'm not good at funny pictures, just in case I don't want to disappoint you as we go through. I want to thank Miroslav Vadkurti, who is from the Fedora CI team, who contributed some of the content on Fedora CI you're going to see as we go along. I've been Red Hat 2009, so I've been working on stuff for a long time. Okay, before we get started, I just want to kind of do a thing. Who here is a Fedora person? Understands how we make Fedora, how it's put together? Matthew, put your hand up. Well, I mean, understand is such a large word, right? It is a very loaded term. Who has no idea how you would put together a Linux distribution, how that would work? Okay. And some people are kind of in the middle. All right. I'm just trying to, because I've written the deck so I can just dive right into Fedora stuff, or we can take it slower, and I'll go somewhere in the middle in that case. I also just wanted to say, if you have questions, generally hold them till the end. But if you're completely lost and you want to be following along and there's a question you could ask that might help you understand, do go ahead and put your hand up and I'll see if I can deal with it. Also, if I talk too fast, please let me know, because that's the thing I tend to do. All right, let's dive in. So yeah, orientation, this is the section that is a guide for people who don't really know how we put together Fedora. So if you know that already, feel free to look at funny cat pictures or whatever you want to do. So yeah, how do we make an operating system? Well, we take things that exist in the world, code bases, bits of software, and we build them. So building them means we turn them into a thing you could put on a computer that would do useful stuff. Then we take those those package builds are handled by a code. So I'm defining what we're going to use later. And then called updates, which is maybe one package build on its own useful with another package work properly, and the update is where you bundle the unit that should work contiguously that we can add and that it ought to work. Those are handled by a system called Bodhi. And a compose is when you take all these little packages, these little nuggets, and you turn them into more useful things. Like if I give you a directory full of 5,000 packages, you can't turn it into a computer that's usable. So instead, we give you images that you can install from. We give you repositories that you can download, upload updates from. And the system making those is a compose process, and the tool that handles composes is called Punji. So these are all things that are kind of come back into it later. Just brief notes there. The sources for the package builds these days are in source control. They're in a system similar to GitHub, kind of, which we're going to talk about later. And there are some differences between stable and development composes, but they're probably not too important. So testing. So once this is how our build process works, but we want to make sure things we build work. That's a good goal. We didn't used to be so hot on that. We get better at it. So all those levels from the previous slide, we can do testing. You can test within control. You can run tests on tests. You can test builds. You can test inline, or you can test a build after it's done. You can test an update to make sure that it's contiguous like it says it is. You can test an entire compose. And these are all things we've done for a long time. The idea of compose validation testing is that we make sure the compose meets the criteria that we've decided a Fedora release should meet with compose validation testing. So we test at all of these levels is the important thing to take away from this slide. So the background to automated testing is manual testing. In ye olde days, as it says on my next slide, and this is around the time I joined Red Hat, 2009, for quite a long time, we did all of this testing manually, except for some very limited exceptions in the first bullet point there. So I spent years just setting up virtual machines on desktop, setting up another virtual machine, installing it a very slightly. This is how we used to do it. So for builds, the only thing we really did you can do when you're compiling the software, you can add a step which runs some kind of checks. It's called a check in an RPM file, and that that's better than you're very limited on what you can test. What we normally do at that stage is just rerun the software's upstream unit tests. We can't really test that it works in Fedora just because of the environment that it runs in. Update testing was completely manual. So I'm going to introduce the system for this a bit later, but basically there's a website you can go to and you can see what updates are currently under testing. You can check if you have them installed and you can provide feedback on them. You can say, does this work for me? Does this not work for me? This was really it. And the team would focus on important updates and we would try to test them. But aside from that, it was, people coming in, and if they happened to be running that, they could test it. And if they didn't, and a little bit, so it was very give like I have my installed system, I installed the test update, my system working, which that's good to know. My system didn't keep working, also good to know. But we wouldn't test whether it broke the process of doing a fresh install or the process of doing a compose, as I talked about earlier, because that was very difficult. It's difficult to do manually. You don't want to run a fresh install every day just to see if an update works, it's quite hard to build a live image or an installer image to see if it works. So I would very occasionally do that manually. Basically, we never did it. And they would break those things, and that was a problem. Finally, for compose testing, this was kind of the biggest focus of our manual testing. This was where we made sure Fedora worked. We kind of came in at the end of the process, this is a legacy way of doing it, right? The waterfall style, you build the thing and then test the thing. So we would come along kind of at the end and we would take a compose Fedora that we were going to release and we would run it through, those 100 something manual tests. And if it didn't work, we would send it back and say, fix it. This was like the best coverage we had, and we did actually do a pretty good job of covering most of the system, but it has a lot of limitations. It's time intensive and boring, as I said. Humans just can't test every compose. We didn't have that bandwidth. So we would test 10, 15 composes a release, but we do a compose every day. Things. If we had hundreds of people, we could test, but we didn't. The limitations of manual testing. So enter automated test systems. We have a long history in Fedora with automated test systems because we've been around a long time. So in the old days, it was mainly my team that was really interested in automating some of these things and solving some of the problems we had. And we had some other systems. There was one called Taskatron, which previously AutoQA, which we worked on for a long time, which kind of fed into Fedora CI in the end. But that didn't do a lot of testing. We did a lot of work on it, but it didn't do a lot of testing. And then finally, around 2015 or so, some colleagues of mine working with some folks at SUSE got really, really tired of all the manual compose testing. And we adopted a system built by SUSE called OpenQA for automating some of the compose testing. And we're going to dive into that later. A few years after that, a system called Fedora CI came to be, which is one of our current systems. And this was more of a planned top-down, well, I wouldn't say top-down, but it wasn't just a bunch of QA guys getting mad and building a thing. It was more of a planned idea of like, we're going to take CI, which is the big buzzword right now, and we're going to apply it to the distribution development process. So we have Fedora CI, and I'll dive into that some more as well. And we have some other things which I'll cover, which they're things that were sort of developed as itch scratches, like by individuals, or there's a bigger, larger project within Red Hat or somewhere else that contributes to Fedora, which got extended to cover Fedora. So we'll cover those too. Because Fedora is an old project, all of this automation tended to get built around our existing processes. So the processes I've just introduced, we kind of wedge our automation in around those. Our basic process of building Fedora hasn't changed a lot for 13 years. In big picture, in small picture it has, but the overall workflow has been very similar. So let's start out with OpenQA. OpenQA is a really interesting test system, as I say, originally developed by the folks at SUSE. So I collaborate with them on it, and it's a really, really productive process. OpenQA is kind of like, it's like a robot intern. And OpenQA was developed by the same kind of QA people at SUSE who got really mad of doing tests manually. So they kind of automated themselves. So if you're running 50 installation tests yourself in a virtual machine, that gets so tiring. So what they did was made a robot to do it itself, and it works very much like a human. OpenQA tends to work. It's been expanded to have more backends. Like the core workflow is, it runs a virtual machine, boots usually an ISO or something in that virtual machine, and then it clicks on things and types things in, and it looks at the screen. It takes VNC connection, which is just a connection, and it can type. It can keyboard events, move the mouse events, it looks at the screen. It takes screenshots, which is kind of neat, every few seconds, and it also takes a video, which is great for reviewing the test result later. And to decide whether a test has passed or failed, it can sort of say, oh, does this area of the screen look like it should? That's kind of the main mechanism. It can also run scripts or just console commands and check the exit code, which is kind of necessary because sometimes you need to test a thing that you run at a console, and it's really stupid trying to match a 0 or a 1. So we built in a way to get that out of the serial console. But the clever thing it does is the screenshot matching stuff. So what OpenQA is really good at is those kinds of things, the kinds of high-level end-to-end tests that QA engineers used to run, where we take a thing and say, can we run an install of the operating system? That's quite if you're looking at it from the other end, that's like a long way down the chain. That's a pretty big advanced test, and it's really neat to have an automated system that can do that. So what OpenQA tests in Fedora is we have a standard set of tests that's run on all composes. So this is the compose from that early slide. Anytime we do a compose of Fedora, we do like a nightly compose of the development release, or we do a nightly compose of something like Fedora IoT. It gets a signal and it runs its standard set of tests on those. It has a subset of those tests, which it runs on updates. So that's the update concept from the early slide. When there's a new critical path update, it gets a signal and it runs like a subset of the standard tests on that update. The reason why, so a critical path update is a concept we have, which is basically just like this is an important update. We have a list of packages that are important, and if a package from that list is in the update is a critical path package, a critical path update, I'm sorry. And the reason we limit to only testing those is just resource constraints. We don't have the hardware to test every single update because that's a very big set. So yeah, OpenQA, the strength of OpenQA is that the thing it does is a really useful thing, and there really aren't any other test systems that do that. There's similar things, kinda, but OpenQA is really good at it, and that's why we like it. The weaknesses of it are that it's not the best place to do what developers might be familiar with and more comfortable with testing, where, you know, the GitHub workflow where you send a pull request and some tests execute in a container and get some results back. You wouldn't want to implement that in OpenQA. It doesn't make sense to do that. So for those kinds of testing, oh, sorry, I have OpenQA test coverage next. I haven't rehearsed this talk. OpenQA test coverage, this is just kind of a summary of like, this is how much we have testing in OpenQA right now. And this is kind of good for the Fedora folks because we've been expanding this out gradually for years. We started this system in 2015 and we just keep adding on to it and adding on to it. So right now we cover 75% of the release validation tests, those that hundreds of tests that we used to have to do manually, 3/4 of them are now done by the robot, which is fantastic. We also added some new tests just because they were useful and easy to implement in OpenQA. And it also covers Silverblue, which is not release blocking, but it's important to Fedora, so we wanted to cover that. The kinds of tests it does a lot of install tests. It tests upgrades, so it can start from, you know, an install of Fedora 35, run the entire upgrade process to Fedora 36 or Fedora Rawhide, and say, did that work? Which is a great thing to have as well. It obviously tests the graphical desktop and applications. That's what it's good at, and that's a really nice thing to have automated. We also use it for testing FreeIPA, which is, it's a Red Hat technology that's kind of like Active Directory. It's an enterprise, you know, user management kind of deal. We test that in OpenQA because to test that, you need multiple machines talking to each other. And OpenQA is actually really good at that, and Fedora CI isn't yet. So we tested in OpenQA. The same thing for database server, and they are critical functionalities of Fedora server, which is the other reason we want to test them. So it can spin up one machine as a database server, spin another machine as a client, talk to the database server, and make sure that all works. And that's all done from scratch as a regular person would do it. An old school regular person would do it. So for updates, yeah, there's a subset of the release validation tests that we run on updates. Plus, there's some neat new, fairly new tests, which it didn't used to do a couple of years ago. And this goes to the thing about making sure we don't break composes. Remember how I said manual update testing? It's really difficult to check that we don't break composes. With a robot, we can do that. So what I made OpenQA is if you feed it an update, it can build like a Fedora network install image or a live image exactly the same way as we do it in the compose process. And then it can boot that image and check that installing it works. So now we have some confidence that updates aren't breaking the compose process. And this is kind of nice for stable releases. It's not very important, but for development releases, it's really important because now we have a point where we can stop updates breaking the compose. And that has been a big pain point for us in past years. Just to give you an idea of, you know, what OpenQA achieves, because a test system that doesn't achieve anything is useless, it files of bug reports. I was trying to get them more detailed. It automatically filed them. I filed most of them. But we filed, you know, hundreds of bug reports for things that I has discovered. Over 200 in Red Hat Bugzilla, but a lot upstream. They go GNOME upstream or they go to, you know, GitLab upstream. So it's hard to get an exact number. We have two instances. We have a, you know, a test instance and a production instance. Between them, they do, I was trying to add this up and I'm tired, but we do simultaneous executions, which is small scale for, you know, maybe if you're used to giant systems, it's pretty small scale, but for Fedora, it's kind of cool. This is all run on regular hardware. I'll cover that later. And we've run over 3 million tests since 2015, which again, if you're a big fancy CI guy, that's not a lot. But for me, I'm kind of impressed for a system that started out. It was running under somebody's desk in Brno, you know, just on Skunkworks server, and now it's kind of a real thing. So I'm pretty pleased with that. OpenQA resources, by resources, I just mean like, how do you learn more about this system, right? So a thing about OpenQA is that it's not very interactive in a way. People come to me and say, hey, can I run my own test in OpenQA? And I'm, well, kinda, but you probably don't want to. It's quite hard. OpenQA is written in Perl, which is a stumbling block. So we kind of run OpenQA as a sort of old school, a service the QA team provides, right? We maintain the core set of tests. We monitor the results. I monitor the results. We investigate failures and we file bugs. So your interaction with OpenQA as a Fedora developer is likely going to be you get a bug report where I OpenQA found this thing was broken. And I will do the work for you of figuring out what the testable really means in context of your application being broken. But if you are interested, we do have, references. If OpenQA does something and you don't understand what it's doing and you're mad, you can come and talk to us. You can contact us on our mailing list. I know these links are a little hard to read. I'm sorry about that. I'm bad at Impress and I didn't know how to change the color. But that's our mailing list address. And on Fedora Chat, which is the current shiny Fedora chat system, we have a room called Fedora QA. That's where we are. There's an upstream site for OpenQA, which is easy to remember. It's open.qa, and that's maintained by the upstream project with all the upstream documentation. And we have a downstream page on the wiki, which covers all of the things related to our downstream implementation of it. So now we go on to Fedora CI, which is the other major test automation system in Fedora right now. OpenQA and Fedora CI are the big dogs, kinda. So again, I want to acknowledge Miroslav Vatkurti, who pretty much wrote this whole slide and gave me all the material. Any errors are my own, not his, and I'm sorry, but I'll do my best. I know there's a lot on this slide. I'm going to go through it. Don't be scared. So where Fedora CI came from, as I said, it was more of a planned effort. There was kind of a fad within Red Hat years ago for CI. CI is the big new exciting trend. We're going to CI all the things. So the way this got communicated down to Fedora was, we think there should be CI for Fedora. Like, everything you change in Fedora, we should find out if it's broken right away. And, the way it does for a small project on GitHub. And we were like, that's kind of hard, right? That's a big that's a big thing. That's a big challenge. But that's where it came from. So someone put together a plan for how to do at least some of this in Fedora. So what Fedora CI kind of is, it's one of those tricky things where it's kind of a more instance which lets you run tests in a way that's more conventional to a developer on Fedora packages, on Fedora package spec files, things like that. So Fedora CI, unlike OpenQA, it doesn't have like a curated set of tests that the Fedora CI team writes and runs. It has a small one, but that's kind of a legacy thing. I'll explain it in a minute. The idea of Fedora CI is that you can kind of write your own tests as a packager. So as a packager, you can, this is, if you want to contribute tests, this is where you do it. So you can, if there's something that it would be useful to you as a packager, where when your package build is done or there's a pull request for your package, a build gets done and then it gets tested somehow in like an environment where other packages are available and so on, and a network is available. Fedora CI is kind of the place to do it. And there is a standard format, which is called TMT, in which you can write not only the test, but a lot of stuff that goes around it. So that's this second bullet point here. You can specify like how the tests get discovered. You can specify how the test environment is provisioned and how it's prepared, which is, what resources do you get? What's the start state of the test? Like maybe you need to install some packages, maybe you need to pull something from somewhere else, not an official package. How does the test get executed, which means you can use other test frameworks. Like you can kind of run any really standard test framework within Fedora CI, whatever makes sense for your package you can use. And reporting, there's a kind of a base expectation of how results get reported, but as long as your test, sends the system back the result in the format it understands, it doesn't care how that happens. So it gives you a lot of flexibility, but there are also kind of sensible defaults for all of these things. So if you want to do something fairly simple, it's quite easy to do that. You don't have to get far into the weeds. It'll give you a sensible environment to just execute some scripts by default, for instance. So yeah, TMT is the current shiny for how you specify all of this. And you can look, I'm not going to explain that because it would take forever, but you can look it up on the source data. Is an old thing, and the takeaway here for Fedora people is TMT is the new shiny, STI is old, do not write new things in STI. Testing farm is kind of it's like as all this has been developed, it's become clear that we have a lot of, when I say we, I'm now talking about the Red Hat Fedora CentOS conglomerate, we have a lot of things that are kind of overlapping, kind of similar. Like there were test systems for RHEL, for CentOS Stream, for Fedora. There's this thing called Packet. There are a few other things I'll mention later, which they shared a lot on the back end. They were all kind of running inside the same Jenkins deployment. And testing farm is kind of the idea of let's view all of these things as one thing. Let's put them together. Let's rationalize them. Let's treat them as a unit, not as a vague series of overlapping blobs. So TMT is part of that effort. And the idea is that it'll make it easier for you to kind of unify your testing so that with limited work, you can kind of tests running in all of these different environments, which would be kind of cool. The idea of Packet is to integrate upstream and downstream development. So if you're the owner of something both upstream, as in the original project, and downstream in Fedora or RHEL or something, you can, instead of having to treat those as two different things, the idea of Packet is to allow you to kind of work on them in a unified way, and testing farm backs that. So what does CI really do in our context of what is getting tested in Fedora? So it runs those tests on all official package builds and also pull requests. So this calls back to the early slide about the different levels. Fedora CI is kind of a lower level thing than OpenQA in general. It doesn't run its tests on updates and composes. It runs its tests on package builds and pull requests. So you're getting your tests to run more frequently and earlier in the process. The trade-off for that is that you can't really test, does it work with this other package, or does it sort of affect the compose process, because you're not at that point in the process. So they're complementary, they're not in competition to each other. It's also kind of a more developer-driven workflow than OpenQA is. You can write the tests and contribute them, and you're getting the feedback in your natural developer workflow. You're not getting a bug report. You're getting, something, we'll see this later, but you're getting feedback in your dist-git or whatever. So yeah, again, just to make the point, they're complementary. You could make OpenQA do a lot of this, but that would be dumb and slow and not as efficient. And you could re-implement all of the shiny screenshot matching things OpenQA do in Fedora CI, but why would you do that? Because OpenQA is already written, so we have two systems and it works out quite nicely. So yeah, CI runs on all package builds, also pull requests, which is kind of a big deal. And CI, the standard test that I kind of mentioned earlier, this is a hangover from that old system I mentioned called Taskatron. The one practical thing Taskatron really did was it ran this suite of standard tests on all package builds. So installability is, can this package actually be installed? Does that work, or does it just throw an error? RPM inspect and RPM inspect is kind of like a correctness check for packages. And RPM deplint is kind of checking the dependencies of the package are correct. So sorry, I didn't explain that in the initial thing. One of the key things of packages is package specifies what other packages need to be installed for it to work. Package build, beyond that, it runs whatever tests the package specifies in its own, configuration. So others are like the other test systems. And they're not, the funny thing about these, they're not all intended to be QA systems. Some of them are kind of QA systems by accident. So Koche is a good example of that. I hope I'm saying that correctly. Koche it was kind of developed as an itch scratch. The idea of Koche is, if you're a package developer, you can sign your package up for Koche and it will just constantly rebuild it, more or less. So the nice thing about that is when somebody else changes something and your package stops building, which will happen, Koche will tell you about it and you will find out when it happened. And from that, it's much easier to find out why. So this was kind of a convenience thing for package maintainers, but it's effectively QA as well, because it's super useful for us to know, hey, when did this package stop working, stop building, and why? So I kind of count that as a QA tool, even though it wasn't intended as one. Fedora release auto test is a really little thing, but it's kind of cool. I wanted to call it out. We have, so our validation, you remember our compose validation concept where we run a bunch of tests to make sure compose is releasable. Some of those require odd hardware configurations. Like my favorite example, which is almost a meme at this point, is that we require that it works on serial attached SCSI disk drives, which nobody has. I don't have any. Matt, you don't have any serial attached SCSI disk drives, do you? No. Well, yeah, there you go. So this was constant. Okay, then you're signed up to do validation testing. Congratulations. But this was a constant pain point, and we had a few other things like fiber channel over Ethernet. There were these exotic technologies that OpenQA doesn't have, Fedora CI doesn't have, nothing has. Why aren't you testing things, Matt? So what we do have at Red Hat is we have this internal thing called Beaker, which is basically a big hardware farm, which has all of these crazy technologies in it. It's kind of an old thing, but it's useful if you need to do this. So my colleague Lily, who is on our team, and she's great, she wrote this thing called Fedora Release Auto Test, which kind of it does similar to OpenQA. It notices when there's a new compose, and when there is, it sort of generates the tests to send into Beaker to test that it installs on that hardware, and then it pulls those results out and puts them into public Fedora record tracking. So that's how we can test on that hardware now, which is great because we don't have to run around trying to find the one person who has this hardware to test it. So that's a neat thing. RelVal is a tiny little tool that actually does the work of setting up the compose validation testing, but it also happens to do image size checks just because that was the sensible place to put it in the process. So we are checking image sizes automatically now. That's kind of the takeaway here, which used to be a big pain point. When you release the distribution, you kind of want your images to be small enough to fit on a USB stick or a DVD, maybe, if people remember what DVDs were, the little shiny things. Yeah. CDs, we still target CD size for some images, I think. But anyway, there's size limits for the images, and we want to make sure they meet them. And we want to make sure that when that stops being the case, we find out as fast as possible. So having that automated is nice. Fedora CoreOS CI is kind of a big thing, but Dusty's not here to talk about it anymore, so I'm just going to call it out here. You may have heard about Fedora CoreOS at this conference. You may not. It's I don't know how you would not have heard about Fedora CoreOS at this conference. It's kind of a special flavor of Fedora, which I won't go into all the details on, but it has its own really shiny CI system, which is what we use to validate that the Fedora CoreOS product meets its requirements. And that is that's just kind of a cool thing that sits there running and I don't have to care about it. So I love that. But the takeaway is Fedora CoreOS has really good testing of its own. These last two, I'm going to kind of skate over a little bit because these are kind of planned to be sucked into Fedora CI, and they're part of that whole testing farm effort that I mentioned earlier. But Zool-based CI is a setup for using a neat CI tool called Zool to run tests on, pull requests at the Forge level, which we'll go into more later. And Packet, as I mentioned, is for integrating upstream and downstream development. So it makes it easier if you're the maintainer of something upstream and downstream. Okay. So this one, it's just a little introduction slide, but I'm going to talk for quite a long time here, so get familiar with it. So that as you can tell from the previous slides, we test a lot. For Fedora people, I hope you noticed that we test more than we used to. Some of those things I talked about testing, we did not test before. My pet hate is automated tests that get run and nobody cares what happens. You've probably seen a test system like this. You've seen a project where it has CI and the CI always fails and nobody cares. I hate that. I am very, very opposed to that. So to me, this is an important thing. Testing is useless unless you have clear, visible, manageable delivery of the results. Like the results have to go somewhere where you can see them. It has to be clear, and you have to be able to investigate. Like this just it failed doesn't give you the tools you need to figure out why is a useless test system. So this talking about how that works. In Fedora, we have kind of different doing this, and probably other people do too, but in Fedora we do. So if we go back to the OpenQA slide, way back here. So this is, oh no, it went too far. So this over here is the OpenQA web UI. I forgot to do a little sidebar here. Right here, you see that it has a lot of green. If you've seen me frantically typing on my laptop most of this week, at the start of this week, there was a lot more red. And I have spent my entire week turning the red into green. It's been fun. But sorry? Oh, I thought someone had a comment. But yeah, this interface is kind of for me and people on the QA team. I would not expect Fedora packages to go and look at the front page of OpenQA. For me, it's great because I can say, oh, this update has failed tests. I better go and look at that. This little icon means I already looked at it, and we can't clear that red, but it doesn't mean anything's actually fine. So this is a great overview for me, but it's not where a packager would get their test results. So I'm going to talk to you about where they do get their test results. The other thing, I need my notes. So the other really important thing about result delivery, and why I say reaction here, is you need to do something about the test results. So for people to do something about it manually, the clear delivery is important. But the really great thing we want to do is called gating. I'm not going to tell you why it's gating, but it's called gating. And what that basically means is to catch when something is broken and stop it there. We don't want the broken thing to propagate. We don't want it to get beyond that point in the process, and that's called gating. So say we're going to talk about testing updates. If we have automated tests for updates, that's great. And if we let maintainers see the failures, that's great. But if we still let the update go through with the test being failed, that's not so great. What we really want to do is make it when the test is that important. It wasn't important, or it was just so hard we didn't want to do it. So that in the past we kind of focused on the compose validation, but the way software development is so fast these days, we want to be releasing new things all the time. We want to be shipping CoreOS builds all the time. These days we want our development releases to be usable. I'm running this presentation on Rawhide, which is our super bleeding edge development version. I run Rawhide most of the time, which would not have been possible in 2009. You would not have wanted to do that. But these days, we want to make that possible. And gating is really important for that. So yeah, there's a problem with not gating just in the context of doing automated testing as well, which is something I fight with on the regular. And it's why I had so much trouble with all that red. If you don't gate, then a failure will initially come in through the one component that broke the thing, but then the tests for every other component you test after that will fail the same way, and this will make you sad. So if you don't gate, what you have to do is identify why it broke and fix it as soon as possible, which I spend a lot of my time doing. I wear a lot of hats at Fedora, so these days I also fix a lot of bugs just because I want tests to turn back green as soon as possible. It's so much nicer if you gate, because then it and you don't spend your life staring frantically at C code you don't really understand why it's broken. So the difficulties of gating are, I would say, capacity. You need the system. People get mad if you're gating on a test that takes 8 hours to run. People will accept gating if the test runs 15 minutes after they submitted the thing. They're not happy if the thing doesn't get in hours and hours. So you need capacity to do that. Reliability. If the tests aren't reliable, if sometimes they fail, not because there was anything wrong with the component, but just because the test is flaky, that's a problem for gating. You either have to make sure that doesn't happen, be super vigilant, just running, it's not a problem anymore. And the other thing we struggle with a lot is what I would call a change introduced in non-covered system. So I simplified the distribution development process quite a lot. You will probably not be surprised to hear. There are a lot of other things that feed into the process, and we do not test all of them yet. I'll come back to this at the end of the talk. So the problem with that is the completely different system or a different source of information that you don't test. And in that case, you're gating. The first thing that fails in your test system will not actually be the thing that broke the test. So having gone over all that, places where test results get handled in Fedora. So I'm going to do so dist-git. Dist-git is basically GitHub for Fedora packages. There's a slang term, a jargon term, Forge, which is any system that kind of works like GitHub. So dist-git is built on a system called Pagger, but that's not important. It's basically like GitHub. So when you maintain a package, you can set it up so that you send in changes via pull requests. And if you do that, these days, your pull request will get a bunch of comments from automated systems. So the one headline Zool is coming in from the Zool-based CI system. And these two down here, Fedora CI scratch build, Fedora CI dist-git test, are coming from Fedora CI proper. They are planning to kind of merge these in, but this is, this is a place where you can get your results. And this happens right now. That's just a random pull request I pulled as an example. That's live. That's all a real thing. So in this system, you get test results for Fedora CI, and there's other things that kind of part of Fedora CI, and you can configure to have gating on these. Like your package can set, thank you, your package can set configuration that says, I want pull requests to be gated on the results of some or all of these tests. And that would mean the pull request cannot be merged in until those tests pass. So that's, that's one of our key requirements there. The requirement that it's kind of visible and clear, that links back to all. Click on this link and you can pull out the artifacts and figure out why things are failing. So the advantages of using this system as an integration point is that it's quite efficient and convenient for developers. It's part of their developer workflow. So that's kind of the advantage. And that's why Fedora CI tends to feed in here, because that all goes together. It's low-level developer-focused tests. This is the natural place to get those results. The other major integration point is Bodhi, which, if you remember all the way back to the start of the talk, is the system that handles updates. So this is where usually OpenQA results feed in here. It does actually include CI results as well. Any Fedora CI result that's for any of the packages in the update, because CI test packages not up, will be considered as a result that's relevant to the update, and it will be pulled into Bodhi. So yeah, and Bodhi rating is automatic for all releases except for live. Any critical update, any of them fail, it goes full. And that's for branched, which is our next development release, but not rawhide, and all the stable releases. Packages can also enable additional gating here. So if you want to gate your updates on CI tests, you can do it in Bodhi. And because no process is ever perfect, although this makes me sad, if your update is being gated on a test failure that you think or know is bogus, there's a button you can press which says, ignore this test failure, I want my package to go out anyway. If you do that and you're wrong, I will be very sad. So please be careful with that button. Neil? I know, and that's why I'm sad all the time, Neil. Yeah. So you'll notice up here I say any other compliance system. That's just because this is built in a fairly generic way, and technically other systems could get results to appear here. You just have to publish results to a certain system in a certain way. So for Bodhi is actually really good at gating these days. We've done a lot of work on it. For the test result display, it has some limitations. If you're a packager, you may not love this view. Some of the problems with it, when there is a failure, it's not always obvious which failure is important. This little thing up here where you probably can't see it, but it says all required tests passed twice. There's a very good reason for that, but it's still stupid, and I would like to fix it. We're aware of these things. We really want this to be a really good workflow. We try and improve them. I'm not a very good JavaScript front-end developer, so it takes me more time than I would like to fix some of these things, but we are trying. If you have feedback on it, please bring it to us. If you want to help and you're a good JavaScript front-end developer, please do. That would be great. And our final integration point is the Fedora wiki. Yes, we use the wiki for integrating Fedora test results. I know this is crazy and dumb. This is just kind of because of history. When we were doing the validation testing all manually, the wiki is where we recorded all the results. And some of that testing is still manual. We need a place to combine automated and manual results. And it turns out, oh, it's really stupid. Wiki is kind of a good way to do this. So it's a little hard to see on the screenshot, but some of the results here have a little robot icon next to them, and they're reported as coming from a user called Coconut. Those are automated results which have been automatically forwarded to the wiki. Most of them come from OpenQA, but the MediaKit ISO size one comes from RelVal, as I mentioned a few slides back, and that all just integrates in nicely. And then just down here somewhere, yeah, we have a result from Moonlight. That's a result from an unreliable biological system, otherwise known as a human. So yeah, we integrate, the manual and the automated tests in the wiki because it works. Oh god, that's an old story. Because the idea of OpenQA was that we would never have to run the manual test, and we could all go and lie on a beach somewhere drinking daiquiris, and it was called Project Coconut. So that's why. Lots of coconut. I'm going to blow through this part really fast because I'm short on time, and it's not very important. But how all this stuff works behind the scenes, there is a lot of technology in this. There's a messaging bus, which is how all those signals pass between the systems. Thank you. 5 minutes. Let's blow through fast. So yeah, OpenQA publishes messages and listens for messages. All of these little things publish messages, and messages are great because you don't have to sit there hitting an API every 30 seconds to find out something happened. The thing that did the thing can just tell you it did the thing. And before we had messages for composes, I had a really horrible thing I maintained, which just sat there hitting a website to see if a compose had shown up. It was awful, and I'm glad I didn't have to maintain that anymore. ResultsDB is the thing from that old system called Taskatron, which turned out to take over the world, which we were really surprised by. It was the one component of Taskatron that's still around and everyone loves it. Red Hat uses it, it's everywhere. ResultsDB is a really simple key value based result storage system. It's literally, yes, please. Greenwave coming up, next slide. I mentioned Greenwave anyway? Oh yeah, that's coming up, don't worry. So ResultsDB is basically just a database with a very simple web API around it. You hit it, give it some keys and values, it stores them. You ask it for a result, it sends them back to you. But everyone loves it, and it's great. The message bus, which is the important thing. So what that means, I'll get to in a minute. So you can get results from it directly. You can for messages. There's lots of ways you can get things out of it. Greenwave is the thing that makes gating decisions. So years ago, a lot of stuff got built. We had this division called Factory 2.0. And at that time, instead of building one thing, you build 15,000 things that do it. Various of these, so this was built as part of a microservices design, about half of which got implemented. So we have this tiny little thing called Greenwave, which just does gating. You hit Greenwave and you say, hey, is this thing gated? And it says yes or no. That's Greenwave. WaiverDB is the thing that handles the button that says ignore these results. It's a similarly tiny microservice thing, and it just stores a list of waiver. And a waiver is basically a record that says this test result for this update was bogus, ignore it. And yeah, so Bodhi, Greenwave uses it as an input to the gate decision. So when Greenwave is deciding if something's gated, check for the waivers. The way Bodhi does its updating is that it listens to WaiverDB for new waivers, and it listens to ResultsDB for new results. And any time it sees a result or a waiver which may be relevant to the update, it updates the gating decision. That process was buggy for quite a long time. I fixed the last bug in it last week. So if you've noticed as a Fedora packager that your gating decisions are weird and don't get updated fast enough or get updated too much, that should be better now. If it's still not better, come and yell at me about it. This part's going to be super quick now. So when I come to conferences, I don't pay attention to everything. And I like to provide services to other people like me. So if you've been looking at cat pictures for the last 40 minutes, but you still want to say you came to this talk, here it is in one slide. Updates and composes are tested by OpenQA. Package request is tested by Fedora CI. Composes are not gated. The result is manually reviewed. Updates are gated in Bodhi. Pull requests are gated in Dискit, and Koche checks for fails to build FTBFS is fails to build from source, means the package doesn't build. That's all of the automated testing right there. Just take a picture of this slide and you are done. What about FTI? It's not. The future. Yeah, I'm pretty short on time, but OpenQA plans, we want to make more tests. So we want to cover all of the GNOME applications, and my colleague Lucas, who is the other main person who works on OpenQA, is doing this right now. So we've already implemented quite a lot. We test the text editor, we test weather, we test clocks. He's writing more every week. I really want to gate rawhide updates, which is a huge step to take, and it will make some packages mad, but I think it's the right thing to do, and it'll make my life easier. So I'm probably going to get mad and do it one Friday afternoon. So look out for that coming soon. Okay, you have got yourself a deal, Mr. Miller. We want to gating composes has been on the wish list forever, and it would actually be less important if we gated rawhide updates, so that why it has a question mark next to it. But one of the old ideas for this whole thing was that instead of publishing any compose that succeeded, even if it was really broken, even if the OpenQA tests for it are like 90% red, if the tests were all really bad and it was completely broken, we would just not publish it. So the compose would exist, but when you hit the public mirrors for rawhide or 37 or whatever, you would not get that content because we know that content's bad. Yeah, I kind of think we should just go to gating updates instead, because it turns out when you gate the updates, the composes are nearly always fine. So we may not think about that too hard, but it's there on the list. I want to cover more arches. We kind of cover AArch 64, but I don't have much hardware, so it's a really small set of tests. PowerPC we only do in staging, because again, we have a lot of hardware. We don't have 39, so it'd be nice to cover them all. More of those tests, like the one that I'm trying to do OSPs right now, which would be kind of cool. And my new best friend, we're going to do this. If we move it to the cloud, I have infinite resources and I can test all the things all the time. So I would love to do that. Yeah, I've talked to some people about it. We can do it. We're totally going to do it. Fedora CI plans. Again, these are all from Miroslav, so thanks to him for that. Yeah, this whole thing to kind of blend in all the bits that are kind of similar. We want to do that. And he wants to sort of, instead of having the standard tests come out in Bodhi, which he doesn't think is a good workflow for those, because it's not integrated with the developer workflow, he wants to focus more on that stuff going to the pull request workflow. That's about it. Other plans, yeah, there's a lot of other stuff we could do. Yes. It's greenwave.fedoraproject.org, but the web UI is very boring. I think it just gives you an API overview. Greenwave you interact with entirely through the API. I will talk to you after the talk about why you're interested in Greenwave, because it's really kind of a behind the scenes thing. But yeah, it's greenwave.fedoraproject.org. I'll give you more information after. Really? Oh yeah, you have to go to the API route. Yeah. Okay, I'll talk to you after and give you more details on that. So yeah, that was my talk. Thank you. I want to thank Miroslav again for the CI stuff. I want to thank Mo for doing this template. And do you have any questions? This is the Q&A section of the talk. Note Q is Q&A. We get a lot of people coming into Fedora QA asking questions about things. And it's like, yeah, thank you, everybody. Questions, Matthew. Oh, there's a guy with a mic. Thank you, guy with a mic.
How many packages have TMT format tests in dist-git?
That is an excellent question, and it's why I wish Miro was here, because I have no idea. But the Fedora CI team would know. I wanted to get someone from Fedora CI to co-present with me, and I sent a message to the team and said, hey, who's going to be at DevConf Boston? They said, nobody. So I am doing it all. I will try and find out for you.
I just like, numbers. But
yeah, I know you
in
love
more
numbers.
seriousness, I think there aren't very many, or as many as there could be. And I think not enough people are aware of this, and something we could maybe have some. Yeah.
Yeah.
Well, yeah.
So I've just realized I forgot to do the resources page for CI. I'm sorry about that. There is I'll get to you in a minute. There is a docs page. There's docs.fedoraproject.org/CI, which does the documentation about this stuff, and that is where you're supposed to go to look at how to write it. So yeah, that is a great takeaway from this talk. TMT is a thing. The whole Fedora CI system has gotten better than it was. If you're a packager and you've looked at it before and you thought, now is a good time to give it another look. There's these shiny new capabilities and a new metadata format. Take another look at it. Maybe you'll like it more. And we would definitely like to have more packages onboarded to the testing. Next question. I'm sorry, I've forgotten your name, but the guy in the check shirt back there. I'm terrible with names. Paul, thank you.
This is not a Greenwave question.
Okay.
I'm just curious in wondering if you're ever going to test on RISC-V, because I've been hearing a lot of stuff in the limelight about RISC-V and how that's a new architecture that people are working on.
Sure. Kind of the same answer that other people have given you to this question. We don't do it because we don't have any hardware. I don't believe Fedora CI has any RISC-V hardware. I definitely don't have any for OpenQA. For OpenQA, I like Arch coverage. If people are willing to give me enough hardware that we can put in a Fedora data center, and it needs to be able to run virtual machines, and it needs to be kind of server level because we need people who aren't at the data center to be able to turn it on and off and update it. Yeah, so we need that. When we have that, we can do the testing. And you're going to get this answer a lot because this is kind of the requirement for any decent scale test system is, enterprise management. If you don't have that, it's not going to get done. Yeah, that would be nice. Yes.
So I'm somewhat familiar with how the test suite works for Fedora CoreOS, and so my question is, are there plans to adopt some of the philosophies and methodologies there within the rest of Fedora CI?
That is a great question. I can't speak authoritatively for Fedora CI. In general, for Fedora, I would say that would be cool. The kind of stumbling block I have with Fedora CoreOS CI is it's not very public. I don't know where it all happens. To me, it's kind of a black box that CoreOS images get built and tests happen somewhere. I trust that the tests happen, but it's, as an external person, I don't have a lot of visibility into them. If all of that was more public and the tests are in a repo, I could look at the results and see how the test flow works and stuff, that would make it a lot easier to get excited about applying those outside of Fedora CoreOS. David, you're holding a mic?
Yeah, you mentioned Blender for or Beaker. I'm sorry.
Beaker. Blender? Did I mention Blender?
Please don't, let's not talk about that. You mentioned Beaker for the hardware, the QA lab. That's something that from the cloud perspective, we have some modifications to the DCI system that make it possible to bypass the Beaker requirement. So we might want to talk about that later. And I wondered if there were plans for that circa software factory.
No, it's not. It's. I wanted to pull that into the talk because it's a neat little system that nobody knows about, and I kind of want to give Lily a bit of props for it. But it's kind of a smaller thing, and it really is just for those like 6 lines on the matrix of weird hardware that we want to fill in. There was a plan a long time ago to have a Fedora Beaker instance and really push on this and make it a big part of testing, and that never really happened. So to me, Beaker is like, it's a little thing we use for this little purpose and it works. So it's not a huge part of my plans, but I am always interested in cool ideas. Yeah. Okay. Yeah, it's like one of those little dirty secrets that people at Red Hat would kind of like Beaker to not be there anymore, but it's so useful you can't make it go away. It's like the wiki. The infra team has been trying to kill the wiki forever, and me and like 3 other people are like, no, we need the wiki. Leave us the wiki. And Beaker's kind of like that. It hangs around. But yeah, I'm not a super expert on it. I'm not responsible for maintaining it. Thank God. There are probably better people to talk to. More questions? Nope. Alrighty then. Thank you all for coming. I really appreciate all of you coming out. It's the end of the conference. It's Saturday. Everybody's tired. So thanks a lot for coming out. And I hope you enjoyed it.
Thanks a lot, Adam, and for presenting the most photographed slide. Everyone, this is trivia from 2 o'clock in the morning. So see you all there.